Assalamu alaikum and welcome everyone. In this tutorial, I am Amna Al-Shahwani, a mechanical engineering student at the senior year. I'll be your instructor for today and take you through a step-by-step cross-flow turbine simulation. It would be on two stages. The first one would be when we have the minimum flow rate, and the second one would be when we open the Birkwood gate to have the maximum flow rate. I hope all of you take the full advantage of this video. Moving on to the informations. So here appears the turbine. But let's define what is a turbine. A turbine is a rotary mechanical device that extracts energy from fluid flow and converts it into useful work. I was always interested in designing a turbine and study the flow movement. So in this tutorial, hopefully I was able to do it. Now we will go through simulation steps. Let's start. Options, add-ins. Scroll down till you see SolidWorks flow simulation. Press OK. It would take a while till the flow simulation appear. Here it's appear. Press flow simulation, then click wizard. Project name. Project name is optional. Choose the name you prefer, then hit next. I'll let it be fluid Amna. Then hit next. Then, from this box, you can choose the unit system. I'll choose SI unit. You can choose any unit you prefer rather than SI unit, then hit next. What type of analysis you want to choose? I'm going to choose external analysis, or as it is called, flow simulation. From the physical features table, choose gravity and rotation. As the gravity would be in the y direction, so let me change this one to 0. And add here negative 9.81. The negative is to reverse the direction as this arrow would show. As the shaft would be, the rotating part, my reference will be y-axis. In older editions of SolidWorks, it would appear reference axis here in here. Please choose y-axis. Then hit next. Then, from fluid table, you can choose the type of fluid. I'll choose water plus liquid. Scroll down till water appear. Double click on the water to be selected. So now water is selected as my liquid. And check the cavitation to know the cavity. Then hit next. Then hit one more time next. Here it comes to the parameters. I'll assume the values. I have to set the velocity of water. Let's assume it would be 100 meters per second in y direction. But don't forget to add the negative sign to reverse the direction as the blue arrow could show. Here it is, the blue arrow. Hit finish button. This box is known as computational domain, and it represents the area of flow. In other words, the water will flow in this area. So, I have to reduce it to increase my computer speed. To do that, right-click on computational domain, edit definition. I can edit it either by these arrows or adding the numbers in here. So, then I'll change this one to 0.06802 7 5 132. And here I can change it to 0.600467165, and this one should be 0, and this one should be 0, and let's change this one to negative 0.379374487. You can have a screenshot and just enter this number by keyboard. Then press OK button. I have edited my computational domain. Here I have to define the rotating region. Right-click on the rotating region, insert rotating region. So, select the shaft, and let's assume that our angular velocity would be 300 rad per second, but don't forget to add a negative sign. Then press OK button. After that, I need to set goals. Right-click on goals, insert global goals. Scroll down and choose velocity in Y direction. Here it is. Tick all these options, then press OK. I have to run the simulation. To do that, right-click on the project, select Run. Then one more time Run. Then wait a while till the calculation table is done. As we can see, now it's preparing model, and now it's calculating our calculations. So the calculation part depends on your internet speed. If you have a high internet speed, it won't take a while, but if you have a lower internet speed, it will take around 5 to 10 minutes or even higher. So as we can see that the calculations is in a progress. So now my calculations are over. You can take a look at these values, then close this window. The result bar has appeared below. Right-click on computational domain and hide it. Expand the result and click on Flow Trajectories. Right-click on Flow Trajectories and choose Insert. 3 options would show. Select the one that holds Pick from Screen. It's this one. Then select the phase to be this phase. Then make sure that the arrow is to the highest point towards the face. Press spacebar and choose top plane. Here is it. Click on Pick Points from here, and I'll select you can select as much points as you like. All points are in flow trajectories. That means the flow will start from these points. For the appearance, you can choose the shape you want these points to appear with. I'll select lines. It's already selected. You can change and choose whatever you like. I'll change the width to be 1 millimeter. And I'll select velocity. You can switch between all these anytime you would. I'll show you later. I'll hit OK. Okay. Okay, as we can assume that the highest velocity is 100 meters per second. So let's assume that the highest velocity would be 110 meters per second. So I'll double click in here and insert 110, then OK. Next step is you can see what is happening inside the turbine. So for that, let's hide the side plates and also hide the bearing. Let's hide this one. And so as you can see that we have the maximum velocity in here. Then we have here some orange colors, then yellow, then it goes to blue. Let's switch between velocity and pressure. Click on velocity and choose pressure. Then hit OK. Here you can see the pressure inside the turbine. Or any other option rather than pressure. So I'll go back to the velocity. I'll hit OK. Okay. So as you can see that the brigade gate is not fully open. So it's not the maximum flow. We should open it by rotating it like this to see how the turbine would show under maximum flow rate. And this is stage 2. To calculate the protractors, we have to run the simulation one more time. For that, right-click on the project and select Run again. Run one more time. The model geometry project setting has been modified. Do you want to reset the computational domain? I'll say no. Flow simulation has detected that the model was modified. Do you want to reset the mesh setting? I'll say yes. So now you can see it's recalculating the flow simulation. Preparing the model, then the calculation. It would take a while. So as you can see, the calculation is in progress. Let's wait a while. So now our calculations is towards the finishing point. And now our calculations is done and we had finished the second calculation. So close the calculation window, expand the result, right-click on Flow Trajectories and select Show. Here you can see the new flow trajectories according to the new position. You can see that we still have the higher velocity in here, then it decreases till it go out. Let's see the pressure one more time. Then return back to the velocity. So, now I have done the second stage of the simulation. So to conclude with, I would like to thank you all for attending this tutorial and hopefully you have a great learning outcome at this video and wish you all a good luck and success in your academic and working life. For any questions, please leave it in the comments so I could reply to it as soon as possible, and goodbye. See you at another tutorials.